Hello again. My name is Chris Dunn, and I'm the director of the Hydrologic Engineering Center, or otherwise known as HEC. This is the third part of a four-part series where we introduce you to HEC's Watershed Analysis Tool, or HEC-WAT. Specifically, in this presentation, we're going to introduce you to consequence and performance metrics created by HEC-WAT and show you how they're similar to what HEC-FDA computes. So in previous presentations, we talked about the need for systems and watershed approaches with risk analysis. We introduced you to the WAT. We introduced you to the flood risk analysis compute option within the WAT. And in this presentation, we're talking about the consequence and performance metrics. And then in the next presentation, we'll talk to you about the field implementations and challenges and solutions of running a tool like HEC-WAT with the flood risk analysis compute option. So net benefits with uncertainty. We talked about this a little bit in the previous presentation, but ultimately you need to get to net benefits, and that's how you develop the NED plan. What HEC-WAT does right now is it computes your expected annual damages without your project and your expected annual damages with project, and then the difference between those two are your damages reduced. So that's what the WAT can do for you now. But ultimately, you need to get to net benefits. So you take your damages reduced minus your expected annual costs, which we would get from a full life cycle cost analysis, and then that would give you your net benefits. So looking at this table below, you can see that we have 6 alternatives, and they start with a 20-foot high levee all the way down to relocation. And then in the next column over is your benefits and your costs. And you can see that your net benefits is just simply your benefits or your damages reduced minus your costs. And so if you look at the net benefits column, which of these alternatives is your NED plan? Give you a second. But it's pretty simple. It's whatever value is the highest in your net benefits. That happens to be relocation at $105,000 of net benefits. So that would be your NED plan. Then we talk about, in the next column over is your standard deviation. In the next column over is the probability that net benefits is greater than 0. And in the last 3 columns is the net benefit that exceeded with a specified probability. So if we go back, let's just say to the 20-foot high levee, you have a 75% chance that your net benefits will be at least 8. And then you have a 50% chance that your net benefits will be at least 54. And then you have a 25% chance that your net benefits will actually be 99, so $99,000. So not only do you have your net benefits, but you have your net benefits with uncertainty. As far as your performance indices, first is your annual exceedance probability. We talked about this, but it's the key element in defining the performance of a plan. It is the probability that a specified capacity or target stage will be exceeded in a given year. For levees, the chance of failure or exceedance in a given year is also taken into account. So HEC-WAT calculates annual exceedance probability at every grid cell and structure. The annual exceedance probability in this instance is the probability of the ground stage being equal or exceeded. And creating a flood map from this data will be a simple raster calculation with a GIS program. So we'll show you that in the next slide. And in this particular figure, what you're seeing is the floodplain on the left. And then there's your house, and you're protected by that levee. And so on the right-hand side will be the calculation of our annual exceedance probability. So let's take flood 1, the first event. And if flood 1 comes in, does your house get wet? No, in this case it does not. So your annual exceedance probability at this point in time is 0. So you have 1 event, you're 0 for 1, okay? Not too difficult. And so in the next flood event comes up, flood event number 2, does your house get wet? Yes, it does. In this case, your house gets wet, and so now your annual exceedance probability is 1 out of 2, or 50%. Okay, so obviously we haven't run that many events yet. So you need to run many, many, many events, but ultimately this is how the annual exceedance probability is computed. And once you have the annual exceedance probability computed, the rest is pretty easy. So theoretically, everybody here should be able to compute the annual exceedance probability. It's just the probability of you getting wet in any given year running hundreds, if not thousands of samples to see if you're going to get wet from a particular event, sample event. Okay. So once you know your annual exceedance probability, then everything else kind of falls into line. So the conditional non-exceedance probability or assurance is that index at a specific target or stage, the top of the levee, will not be exceeded given the occurrence of a specified flood event. So in the circle, the red circle on the right-hand side of the figure, we typically look at assurance as the red scale, where we say, well, 87% of the 1% stages, or the 1% flood, or the 100-year flood, are less than 70 feet. So let's say the top of your levee is 70 feet. I can say that we have an 87% assurance, or 87% probability of containing the 1% chance flood, or containing the 100-year flood. Okay. When we use an FRA compute option, we just turn the scale on its side. That's the blue scale. And now we say 87% of the annual exceedance probabilities for 70 feet are less than 1%. So it's saying the exact same thing. It's just turning the scale on its side. And so you now have 87% of containing the 1% chance event with a levee of 70 feet high. Okay? So again, it's really all about knowing your annual exceedance probability. And we just showed you that that's pretty easy to compute. Same with the long-term exceedance probability, or the probability that one or more flood events will occur within a specified time period, or the likelihood the target stage will be exceeded in a specified time period. Okay, so we typically look at the 10, 30, and 50 years. 30 because that is the normal life of a mortgage. Okay? And so the calculations are made directly using the binomial distribution, which you can find in EM 1110-2-1415. So the long-term exceedance probability is equal to 1 minus the annual exceedance probability, which you calculated earlier, to the nth power. And the nth power is a term of interest, that is the 10 years, the 30 years, or the 50 years. So again, once you know your annual exceedance probability, very easy to compute your conditional non-exceedance probability, very easy to compute your long-term exceedance probability as well. Okay. So explaining risk through inundation maps, we talked about this before as well. So inundation boundaries and depth maps are viewed and used for consequence estimates, but also a great way to inform the public of risk. So let's take a look. This is a river system. We modeled the river system itself in 1D, but if the levee were to fail, and the levee will fail over onto the right-hand side of the figure, you'll see the water come into the inundation area, or into the interior area, and you'll see how the water spreads in the interior area. So a 1D model in the interior area can show you where your water gets wet, but a 2D model can also show you how soon you're going to get wet. So this is very important for emergency action plans, for telling people how quickly they have to get out of harm's way, and that type of thing. But running a 2D model, now we can not only show you who's going to get wet, but we can tell you when you're going to get wet. And so a great way to inform the public of the risk. So life loss, HEC-FIA within the FRA compute option can do life loss estimations, and care needs to be taken to make sure your parameters match the real life data, but ultimately you can get life loss calculations out of HEC-WAT through the FIA and the FIA plugins. So we have completed the third of 4 presentations in this series, Introduction to HEC-WAT. In this video, we presented the consequence and performance metrics available from an HEC-WAT analysis and verified that HEC-WAT provides the same metrics as HEC-FDA does and as required from ER 1105-2-101. Now would be a great time to capture any questions you have on this session, and we can discuss them in our last discussion session. Thank you. See you next time.